Good morning. How's everyone doing this morning? Good, good. Welcome to Constructing Modern UIs with SVG. My name is Tim Thomas. I am a UI architect with Vector Networks in Austin, Texas, where it's a little bit darker for most of the day than it is here. But the weather's not nearly as good, so I'm very happy to be over here. And I am pleased that I get a chance to talk to you today about one of my favorite technologies on the web, and that is SVG. So if you haven't heard of SVG, we're going to go into a bit of a brief intro today, and then we'll go a little bit more advanced. But don't worry if you haven't heard of it before or not quite sure what it's about. We'll definitely talk about that. So today we've got three main points. First of all, we're going to, as I mentioned, go into a brief overview of what SVG is and how it's used and so forth. Then we're going to take a dive into how to integrate it with some frameworks that you might already be using and other ways of getting it built into your applications. And then the majority of this talk is going to be kind of a deep dive into some of my favorite techniques that I use when I'm using SVG to design interfaces. So let's get started. SVG is an initialism that stands for Scalable Vector Graphics. A lot of this is not super necessary to understand exactly what it does, but I wanted to take a moment to kind of go over what these mean exactly. So I'm going to go in reverse order because I think it makes a little bit more sense that way. So the G stands for graphics. Fair enough. Like, that's probably why you're here. You have probably understood that part already. Here's an example of an SVG image. For whatever reason, this tiger seems to be everywhere on the internet regarding SVG. I don't know why exactly. It kind of looks like a mascot from when I was in school. But it is a pretty good example of the kind of thing that can be done with SVG. So if you do any kind of research, you're probably going to run into this tiger at least once or twice. So graphics part, we display pretty pictures, right? All right, there's got to be more to it than that. The vector is, as far as I'm concerned, the most interesting part about this. So there's two main types of images that we have access to and that we can use on the internet. And one of them is vector images. And vector images are geometry that is defined by points and curves and things of that nature. So as an example, this tiger here, is defined with a lot of points and a lot of curves and a lot of fills and strokes and other pieces of geometry. And what that means is that you can resize it to any size and it still looks fairly crisp because we're not converting everything over to pixels. SVG is not perfect for every scenario. In all honesty, if you made this tiger a PNG or a GIF or something like that, it's probably going to be a little bit smaller than the comparable size of SVG. But it is at least a decent example of what the type of thing you can do. So let's contrast this little exploded view of part of the tiger's face with what it might look like in the other format. We've probably all seen this before. This is a raster image. It's also called a bitmap. It's a bunch of pixels, right? So if you scaled up this tiger to a almost silly degree, this is what you would actually see. Not perfect, especially in today's world with all sorts of different device resolutions on screens and so forth. You don't want to have any of your users seeing pixels anywhere. Like it's not, I don't know, it's just sort of a messy thing, right? We have better options at this point. And then the last bit, the S is for scalable, as we've already talked about. You can make this any size that you want, and we'll see some examples of this later in the talk. Ironically, Keynote, which I'm using for this, does not support SVGs, so this is actually, it's a little bit of a lie. This tiger is a PNG, but it's at the right pixel density, so as far as you can tell, it's still an SVG, but I can't actually scale it at this point. If I did, you'd be able to see the pixels. But believe me, that's what the S stands for. That's usually what is there. So why would you use SVG? One of the best reasons that I usually talk to people about is that it's not a flow-based layout. And what I mean by that is a lot of the web with HTML and so forth is one document node after another. So you'll have two paragraph tags with some text in them. When you render it into a browser, you see a paragraph below another one. And that's because much of the web was designed to show documents, right? We've known this for a while, and documents have a fairly predictable flow. And when we tried to do weird things with this flow, like using table layouts back in the day, kind of got our hands slapped a little bit. Like we weren't really supposed to do that for a number of reasons. But here we come with SVG, and it doesn't have a normal flow-based layout. And one of the reasons is it is designed primarily for graphics, and graphics don't necessarily follow the same kind of strict hierarchy that a book or a publication of some kind would follow. So we're a little bit less constrained on the way that we arrange our objects inside of SVG. Another reason that I usually recommend people at least give SVG a try is it's got some very interesting visual effects that are very difficult, if not impossible, to accomplish with CSS alone. And we'll look at a couple of examples of that here today. And finally, why not? It's out there. It's supported by all modern browsers. You can use this today. Let's play around with it. And as an industry, see what we can do to push the envelope in the way that we're designing UIs. I think recently we've gotten into a trend of specific website layouts and visuals and things of that nature. Well, let's mix things up a little bit. Let's try to use some technologies that we might not be super familiar with. And hopefully by the end of this talk, you'll at least be inspired enough to play around with some SVG. And if you do get a chance, I would love it for you to let me know the types of things that you've worked with it and what you think of it. So there's a number of different ways that we can utilize SVG, and we'll see some examples of this later, but as an overview, kind of the four main categories that I tend to put SVGs in. On the one end of the spectrum are glyphs and icons. So very simple shapes, maybe only one color, one or two colors, not a lot going on there. And you can use them in a number of places inside your applications. On the other end of the spectrum is full applications. And we'll actually see an example of this later in the talk, where one whole app is built with nothing but SVG. And in the middle are a couple of other things. One is visualizations, which we'll talk about in a couple of slides, but visualizations such as graphs and charts and that sort of thing, maps. And then next to that is I've described it as components. So this would be, I don't know, a React component if that's your framework of choice. And all of these are sort of on this spectrum between very, very small and not a major player in your application all the way to it is your application. And one of the benefits of SVG is that it is very flexible. You can use it for one or many or all of these things. It's also very opt-in-able. In other words, you have a normal web app currently, and if you want to start playing around with SVG, you can add it into one or two places and not have to seriously adjust the way that your app is running. So there's a few ways of actually creating SVG, and some of those are a little more efficient than others. To start off with, we have by hand. SVG is an XML-based language, if you will, and it is perfectly possible to write directly into your HTML file some SVG. In this case, we're going to start defining a rectangle using the rect keyword. Yeah, it's fairly manual. I really wouldn't recommend this. It's great to start off with, doing a couple of demos, but can you imagine having to do the tiger with this sort of manual thing? Forget it, not really going to happen. So fortunately, we have a lot of apps in the industry that can help with this. Now, I've featured three here. The one on the top left is Adobe Illustrator. Next to that is Sketch. Both of these are commercial apps with varying levels of features. The one on the bottom is called Inkscape. It's an open source project that has the benefit of actually using SVG as its native file format, which means that anything you do in Inkscape is sort of by definition supported in SVG. Sketch and Illustrator, unfortunately, are a little more feature-rich than the SVG spec necessarily allows. So there's maybe a couple of scenarios where you try to save something as an SVG and you don't get quite the outcome you were hoping for. But nonetheless, these tools are generally fantastic. There are a number of other vector tools that you can use to generate SVGs. And technically, if you want to, you can put raster images inside them too. We'll see an example of this later. But if you are tired of doing it by hand, definitely check some of these out. I think Sketch and Adobe Illustrator actually have trials as well. So if you're not quite happy with the feature set of Inkscape, give them a shot. So we are programmers here, so another option that we have is to use code to generate some of our SVGs. So here you can see an example written in HTML bars, which is a variant of handlebars. And because SVG is a normal markup language, we can put it right there in the middle of the rest of our template language. So in this case, I've got some sort of array that I'm calling shape, and then it has individual items within it that we can pass into this path property. And path is a tag that SVG uses for arbitrarily shaped lines and squiggles and all kinds of curves and things of that nature. And so we can use this, and this will get generated at runtime along with the rest of our template stuff. Right? Success, hopefully. But there are some more abstractions that we can take a look at. These are some of the more popular SVG libraries. SVG.js and snapsvg.io have sort of their own internal spectrum. In some cases, you can use these things to generate new SVG. In other scenarios, they're really better for transforming existing SVG. I do encourage you to check them out and decide for yourself which one might work for your scenario. The last one I'd like to call out is D3.js. Very, very popular data visualization library. One of its options is to render everything inside of SVG, which is actually a fantastic way of looking at some of the more advanced scenarios and different visuals that you can create with D3. So they have some amazing examples on the D3.js site. Definitely check that out. I wouldn't necessarily say that I would reach for D3 if I'm trying to do a full user interface in SVG, but it is definitely great for the visualizations and again is a decent learning opportunity too. So next, let's take a look at some integration points and how to actually use these things in our applications. There's three primary ways that you can integrate SVG in your app. One is with inline declarations. You can also use references. And then the third we'll get to in a moment is using this special SVG tag called use. So to get started, this is inline. It is another bit of markup. SVG is a perfectly valid HTML tag, so stick it directly in your HTML. In this case, we're creating a rectangle that belongs at x coordinate 0, y coordinate 0. It's 100 pixels wide and 100 pixels tall. And now we have some SVG in our application. Fairly simple to get started with this. Now, if you are using something like React, you can go this direction and put it right there in the rest of your JSX, and it'll render as normal. You can put other React components inside this SVG. You can pass props around. Anything that you'd normally do with standard HTML, you can do with SVG inside of React. Now, the next thing that we can do is reference SVG much in the same way that we would with images or other CSS files. So this is a little CSS snippet, and I'm adding a background image of a logo to our mythical logo element someplace on the page. And because this is a background image, we have access to all of the normal CSS properties associated with that. We can resize it, we can change its tiling, all sorts of things like that. The one thing that we cannot do here is we cannot style this with CSS. Because it's a background image, our code, other CSS in this style sheet, for example, has no access to the underlying SVG. So if you go this direction, make sure that your SVGs are already in the proper formats and colors and things of that nature that you want, because once you go this direction, not really another choice other than to use whatever the SVG document has. But there's this use thing. And this is one of my favorite features of SVG. And it was actually, I think, even supported by something like IE 11, if memory serves. Don't quote me on that. But fortunately, we don't usually have to worry about IE much anymore. But what this does is takes the SVG from an external file. So in this case, we have a file on the bottom called glyphs.svg. And this could be an external file that your server could serve up for you. And by using this use with an href, we are opening that file. So we're gonna grab it from the network, and then the browser actually pokes into that file and looks for an element with an ID that matches the hash parameter that we have given it. Now, we'll talk about what this symbol document is in a moment, but the important thing now is it has an ID of favorite, and then our URL that we're grabbing also has favorite in it. So what's going to happen is the browser will create a little SVG document, which we have our wrapper SVG element there, and then it will pull out the symbol from this external document and put it in the DOM with some shadow DOM magic. The benefit of this is that we can style this with CSS, but we are still referencing an external file that can be cached by the browser, and we can update that independently of the rest of the application. Now, we use this at my company Vectra a lot. In fact, most of the icons that we have in our application are served up this way. And the reason is we have 2 or 3 dozen different icons. And the way that we author them is through Adobe Illustrator, and each one has its own artboard, which is a feature in Illustrator that lets you separate artwork. And we export them all to individual SVG files. And those are what get stored in source control. So when we need to make a change, we don't have to export everything. We just export the one file that changed. And as part of our build process, we take all of those SVGs and combine them into one SVG that has a large number of these symbol declarations. And then our main app itself uses these use directives and grabs the symbol that it needs, puts it into the shadow DOM, and that gets rendered onto the page. And again, because of this approach, we can style these things with CSS. So we have the option of adding custom colors to them, hover interactions, all kinds of cool stuff like that. So speaking of styling, there are 2 main ways that we would normally go about styling SVGs. One is with attributes, and one is with CSS. So let's start with a basic rectangle. Now, for the sake of clarity, I've removed the normal attributes that would define things like this square's location on the page, width and height, and technically when you define an empty element like this, it's black instead of white. But if you ignore all of that, we have a rectangle here, right? So let's say we wanted to start putting some styles on it. So one of the things we could do is simply add a directive, an attribute, and give it a color. So we've now filled this rectangle with this color. Now, you may notice that fill is not a CSS property that you are likely used to. SVG does include its own set of attribute names and CSS properties that don't necessarily match up to what we expect with CSS. One big example of this is with the text node. So in normal HTML, you just type some text, and then the browser knows how to style that as normal text. You might use something like the color attribute in CSS to give it a color. Well, the text nodes in SVG behave a little differently. Because they follow the SVG spec, they actually use this fill attribute, much like this rectangle is currently doing. So there's a little bit of translation you'll have to do. I've got some links at the end of the talk that have a lot of the CSS attributes and other attributes, the SVG attributes that you can use to style these things. But do keep in mind that sometimes you'll expect the attribute name to be one thing and it's actually something else. So continuing on, we can add a stroke onto this rectangle and give it a different color still. So stroke instead of border, fill instead of color, things like that. They're reasonably similar, and in fact, if you use any of the tools that we talked about earlier, these terms are used in those applications. So these aren't just arbitrarily defined. They're actually somewhat well known in the graphics creation industry. So if you talk to somebody about the fill and the stroke of an object, one of your graphic designers possibly, they'll know what you mean, and you just have to sort of translate that mentally to say, oh, a stroke is actually sort of a border CSS, if you will. Now, can actually go a little bit further than this. Rect happens to have a couple of attributes that help you define rounded corners. And in this case, we specify an X radius and a Y radius, and making them the same gives us this nice little rounded square that we have here. Again, instead of border radius, this actually has a slightly different function to it. Now, we learned a while ago that putting a lot of this style stuff in our CSS is probably in our HTML/SVG is probably not the best idea in the world. So we can still use some CSS to style these things. The CSS spec does allow you to specify certain attribute values inside a normal CSS file. So things like fill and stroke can still be used here. There are some exceptions, such as the radii that we have established here. I don't know that there's a hard and fast rule. I haven't necessarily found one in terms of what is and is not supported in CSS. Generally, though, I found that any attributes that change the geometry of a shape, so in this case, we're actually rounding the corners, are typically not supported in CSS and something that you have to do directly on the SVG element. All right, with that, I think we're going to skip into our advanced SVG. So I've got a few demos I'd love to show you today. These are 5 of some of my favorite tricks that I do with SVG when I get an opportunity to. And then at the end, I actually have a real-world example of an app that I built using, again, only CSS, SVG and CSS. So we'll take a look at that. So to get started, our blend modes. If you've ever done anything in Photoshop or Illustrator or any kind of graphics program, you've probably come across blend modes before. The idea behind a blend mode is that you have 2 overlapping objects, and instead of simply allowing one of the colors to sort of show through, there's a custom mathematical formula that gets executed and gives you in some cases, completely wild and wacky color. So on the top left here is a normal blend mode. So anytime you specify an opacity in CSS or anything like that, this is the type of blend mode that gets used. You don't even have to specify it, it's just normal. And this allows some of the colors underneath to show through. In this case, I have a picture of the city that I took from my hotel room a couple of days ago. And I've put a box on top of it with a gradient. And again, top left is normal. The gradient box has a 75, 80% opacity to it. So it's a little bit transparent. You can see a little bit of it through there. All of the rest of these boxes also have a 75 or 80% transparency. I forget exactly what number I used, but the only difference is they're using a different blend mode. So the 2 in the center, the one on top is called multiply and the one on bottom is called color burn. And these, again, just have different mathematical formula that produce the color that you'll see on top. So multiply is fairly easy to explain. You take the RGB values of the bottom layer, multiply them by the RGB values on the top layer, and then you display whatever color comes out the other side. The ones on the right, the top one is screen, and the one on bottom is color dodge. Same general principle, but more of a division thing. So you end up with colors that are brighter than with something like multiply or color dodge or color burn. These are just some examples. There's a few others, but these are usually the ones that I end up using most often. The one that I use most often that is not normal is in the bottom left, and that one is called color. Now, if we want to define this, we can use a nice CSS property of mixed blend mode, which does work outside of SVG, by the way. So if you're curious about how this reacts with your normal HTML, give this a try. Color is one of my favorite blend modes because honestly, some of the other blend modes look a little bit weird. Like it's not an especially pretty image that it necessarily generates, but color just adds this beautiful tint onto whatever you put it on top of. So I didn't do any color correction or anything on the image below. I just sort of snapped it with my phone, cropped it down to a square, and put it in the slides. And then I put this overlay on it, which just adds this tremendous amount of depth and beauty to it. So color is absolutely my favorite. Now, if you want to use any of the other blending modes, same general principle, just change the mixed blend mode to multiply, color burn, color dodge, something like that. But again, standard CSS property, so you can use it with normal HTML too. Blend modes are especially helpful if you're trying to do a specific type of branding. So I'm assuming that most of you have seen the NDC website. They do a great deal with gradients, and they have some fantastic gradient colors on their website. I actually really like the NDC website. One place that they could improve, though, is they can add some blend modes, and what that would mean for them is they could actually use pictures of, let's say, the spectrum here, and overlay their gradients. Because the gradient is such a key part of NDC's branding, this is a way of being able to swap out the underlying image without having to send it over to your graphic designers and have them slice up another Photoshop picture for you. So you can take any photo, apply a color blend mode to it, and in this case, it'll give you a really nice branding. Also, a lot of photo filter apps do something similar to this. There are a couple of different ways of applying photo filters, but usually they end up using some type of blend mode. So keep that in mind if you're ever making some sort of Instagram clone or something like that. You can overlay any kind of over image. It doesn't have to be a CSS gradient, which is what I have here. You can use another photograph. You can use another SVG object, anything that you might be interested in. And because it's CSS, the browser will take care of all the calculations for you. And then finally, you can actually do some really interesting things with full UIs with this technique. So I'm going to leave you in suspense for a little bit, because we'll talk about this at the end of the talk when I show you the full app that I've made with SVG. But there's some fantastic different things that you can do with the math that's involved with some of these blend modes. So next is an interesting sort of development that I've seen in SVG in the last couple of years. And that's using SVG to actually draw things on the screen. This is actually SVG. I took a video of it, and what happened was I drew this on my iPad in a vector program and then exported it to SVG. So I got one solid path that represents the word of Norway. And then I brought it into a browser and animated it so it looks like I'm actually drawing it in real time here. I've seen a couple of places where this is done fairly well, but generally it's kind of a distraction, so I'm probably going to get it off the screen pretty quickly. But fortunately, this is actually very easy to do with SVG. There's 4 main steps. The first thing we're going to do is create a path. So this is the path tag that we saw earlier. In this example, I'm just going to use a straight line, but any single path would work just fine. So we're going to start with this, right? Simple path. It has some sort of length to it, and that will be important in a moment. But that's all it is. We have a path. So next, we're going to create a dashed stroke for it. So we can define dashes in many of the same ways that you might have used in any graphics tools. You specify one number that is the length of the dash, and another number that is the length of the gap in between those. So just as some default values, I've got this that sort of looks like the start of a road with some striping on it, and that's sort of where we'll begin. Next, we tweak those 2 values until we get something that looks a little bit like this. So let's assume that this line was 100 units long. Well, if we created a dash array that had 100 units of solid color and then 100 units of that gap, then we could actually tweak wherever that line started and actually be able to make it look as if the line is being drawn on the screen. That's exactly what we're doing. Now, SVG uses a dash offset to calculate that, and so you can tweak the values there, and the dash will start at before the beginning of the geometry, and then as you animate it, it will slowly move into being, and then you get your nice little animation. And so the last thing we need to do is actually animate it, which fortunately we can do with CSS. So I use some CSS keyframes to accomplish this. You can see the stroke dash array. This took a little bit of tweaking. It's not quite as straightforward as just saying, oh, it's 100 pixels and then 100 pixel of blank. There's a little bit more at play there, and it actually took me a few minutes to get the sizes right on the dash array and the stroke offsets. So ideally, it would be 0 and 100%. That was not my experience. This is so that the slides look clean. My values were like 0% was 420 something percent, and then 100%, the completed animation was 760 somewhere. Again, a lot of trial and error, but fortunately, and this is another strength of SVG, because it's so well standardized and it is a graphics language, it's fairly consistent in the way that browsers draw it. So I don't have to worry about this suddenly being a totally different animation on a different browser. So CSS with one single SVG element that represents this path. And there you have it. I do recommend that you use this approach sparingly for several reasons. One, it's a little bit of a niche interaction, and it's already really showing its age. It was really novel and cute for about 3 weeks, and then everyone started hating it. And I think some of the reasons for that is they are a little bit tricky to create to begin with. they're difficult for people to consume visually. It tends to drag your attention away from any other parts of the page. You may have already seen this in the slide deck here. It's so tempting to stare at that instead of the rest of the content on the screen. If the animations actually have real information behind them, you have to wait for the whole animation to finish before you can actually see what's going on there. So definitely use this one sparingly, if at all. It is, however, a lot of fun to make. So if you get a chance, make one. It's really cute. It's like, oh, look, I drew that. There is an article by Polygon a couple of years ago, I believe, that did some fantastic line drawings of all of the different gaming consoles using this technique. And it was really cool, but again, very distracting, but still really cool. The next topic we're going to move on to is that of symbols. So in most applications, presumably, you have some sort of thing that you need to show in more than one place. This is the visual version of Don't Repeat Yourself. You have bullets that appear on every line item. You have little triangles next to your column headers that change position and things like that. And so symbols are a way to solve for this. And we looked at some of these earlier when we had our use directive. So defining a symbol, you have a symbol tag. Inside of that, it's up to you. Everything else is normal SVG from this point in, but by wrapping it in a symbol, we get some interesting behavior out the other side. So in this case, let's assume that we have a path that sort of represents this file document icon. Now, because it's in a symbol, it's not rendered to the SVG yet. We haven't done anything with it yet. It's just going to sit there and wait for us to use it somehow. And we do that with another use attribute or tag. So we can reference this symbol from inside the same SVG document in much the same way that we would from an external document like we saw before. So in this case, I'm going to use an href and reference that ID, so #doc, and suddenly we have a document on the screen. And it shares the same geometry as the symbol, which means if we change the symbol's geometry, suddenly all of the symbol instances get updated as well. But we can go a little further than this. We can actually style this as well. So I'm using some inline styles here to keep the code brief, but you can absolutely style these with CSS as well, any of the other things that we've already talked about. So I can make multiple copies of these, make them in different colors and shapes. I can apply CSS transforms to them to make some rotate or flip or be larger or smaller, any number of different scenarios. But this core geometry, what makes this thing the symbol of the document, stays the same until or unless I change its underlying geometry, and then all of the symbol instances will get updated. As I mentioned before, we use this quite a bit at Vectra, not only to reduce duplication, which it definitely does, but it also helps us compose different symbols as well. So we might have one symbol that represents a check mark for something good that happened, and then we might have a couple of other symbols. So we might have one symbol that represents a computer, another symbol that represents like a clipboard, and we can actually put these different symbols on top of each other and make entirely new symbols out of them. So there's some really, really fantastic stuff that you can do with symbols. And then, as I mentioned, they're perfect for glyphs and icons. You can use them for anything, but I've found them to be most effective when you use them for any type of iconography that you have inside your application. So the next thing we'll talk about is clipping. And this is, again, the same picture I took out of my hotel room, and we've just got a nice geometry around it, and there's nothing behind it, right? So this started off as a square image. We wanted to actually add a little bit of flavor to it, so we put it inside of a circle. How do we do this? Well, the first thing we'll do is define what we call a clip path. And this is geometry that we will eventually use to put, in this case, our image inside. Now, you may notice this is inside of a defs tag, and this is another way of defining things that are sort of metadata for your SVG. So we're not going to render a clip path necessarily. Because of the definition of a clip path, it has no inherent rendering of its own. It's just geometry. We couldn't render it if we wanted to. And so SVG lets us put all of this inside this defs collection so that it doesn't get mangled up with the rest of our SVG tags. Once we have this, we can start adding some geometry to it. In this case, I'll add a circle. Now, one of the things that I want to call out here, you may notice this circle's definition is slightly different than that of a rectangle. So instead of specifying an X and a Y and a width and a height, we instead represent this circle's position with a CX, or center X, and CY, center Y, and then R for our radius. There are other elliptical types of symbols, but this one is specifically for drawing circles. So slightly different from one object to another. Another thing to kind of look out for if you're doing a lot of manual entering of SVG. So we've got this geometry. Now let's actually try to do something with it. So before we do that, we have to bring in an image that we will try to clip. So I'll add a simple image tag. Again, minor inconsistency. HTML uses IMG. SVG uses the fully spelled out image. Many of the attributes are different, so again, keep that in mind. But what we're doing here is specifying a width and height. Again, you could do this with CSS. And then an href, which is sort of like the source attribute on an image that points to whatever the image we actually want to display is. So in this case, we've got our clipping path on the left. We have our image that we want to clip on the right. Now we just need to make that happen. Unfortunately, there is an SVG attribute that helps us with this. So clip path will actually make the clip object and apply it to whatever thing you're trying to clip. In this case, it's our image. And then you get this result. Now, this isn't the exact result you'd see. I actually left some of the borders so that you would see what part gets clipped out. But in this case, if we did this in full SVG, it would be what we saw at the beginning, which is a perfect circle with nothing around the corners. Now, this is slightly different of a syntax than we saw earlier with some of the use stuff. Instead of simply putting href equals and then some sort of ID, because the clip path object is inside defs, you have to use this URL function. It's very similar to the URL function inside of CSS if you're trying to load an image from an external URL. I'm not super thrilled about the inconsistency here, but it's a relatively minor complaint, to be honest. And it's easy enough to read and understand that this is going to grab from the defs collection and look for an element that has an ID of mask on it. Much like the hand drawing stuff, I usually recommend to use this approach sparingly. There are a couple of reasons for this. One is if all you're doing is taking a big image and then cutting off parts of it, then do that inside like a PNG, and you'll save yourself the extra bytes of loading all of the data around the corners. So don't do this exact example with SVG. If this is all you're doing, just do all of the clipping inside of another graphics program and export that. That does usually mean, though, when people do a lot of these sorts of clipping things, anecdotally, people just like doing it with photographs. You can do this with any other SVG attribute or group of elements. So you could create this really elaborate sort of bubble thing and then add another bubble on top of it. The possibilities are endless, but again, it seems like everyone usually uses these with images. So be aware there. Also, I just think stylistically, this is not as in vogue as it used to be. We've sort of gotten away from this sort of porthole image viewing thing. But by all means, if it fits your company's aesthetic, if it fits your website, at least give it a try. If nothing else, you'll learn how to use clip paths in SVG. So the last thing I'll talk about in our advanced section, and one of my favorite is the use of filters. And this is what we're going to try to accomplish today. So we have to start somewhere. So let's start with this. At the very bottom, we have a text node. Now I've added some styles elsewhere that give it a typeface and a size and a color. And other than that, all I've done is add this filter CSS attribute. You may have already seen this. The filter attribute in CSS has been around for a while. In fact, it predates many of the other attributes that we used to use for some of the same stuff, like drop shadows, for example. Way back in the day when the DX transforms with IE, I don't know, some single number version of IE, did something very similar to this, and it's kind of come back in the form of these filters. So what we're saying is, whatever is in this filter tag, which we will define at the top of this list, we're going to apply that to our text, and we'll see what that looks like. This is where we're going to start. So up to this point, we've just had some text. We've applied a filter, but there was nothing actually in the filter. We're going to start with this thing called FE turbulence. FE is short for filter effect. Now, turbulence is an interesting filter effect in that it doesn't really do any filtering itself. It's more of a generator. It's going to create some visuals that we will use in a separate filter to do some interesting things. But this is an example of what it generates. Now, this is all of the SVG that we're using. So it is still using the geometrical bounds of our text and putting something in it. So I guess in that regard, you could technically say that it is indeed filtering, but it's not super useful. We've got a couple of attributes here that I encourage you to kind of play around with this a little bit. Base frequency and number of octaves will give you very different effects for this, this turbulence. There's also a type of noise, which is more of like a television snow white noise type of appearance. This turbulence, as you see, has some colors in it. It's got some interesting definition there. I just like it if I need some level of randomness in some of the designs. So it's pretty cool, neat to play around with. One thing I'd like to draw your attention to is the last line of this turbulence definition, and that is result equals turbulence. We don't really have full variables or anything in HTML, but this sort of replicates that a little bit. What we're saying is for the filter object, we have this generator, and its output context, it's all of the data that it created, all of this neat little visual thing, we're going to sort of assign to this variable called turbulence. And we'll be able to use that as a reference in other places, such as with a filter effect displacement map. Now you might notice in this case, we've got two properties or two attributes. One is called in and one is called in2. So in is a keyword that filters respect called source graphic. This is going to take the pixels and the other visual data from what we started out with. In this case, it's just our text node. And it's going to feed those into this displacement map. And it will do that along with the things that are in2, which is the result of our turbulence. So this displacement map is going to take our normal visuals and mix them with this turbulence and then do something interesting and spit out some result. In this case, what we can see on the right. Now, it has its own level of attribute changes that you can tweak. The scale is simply how large or small the value is. Then you can also use these channel selectors, which I won't go into a tremendous amount of detail on these, but what the displacement map does is it takes the RGB values of each pixel and then manipulates the underlying visuals pixels from, in this case, our text node, and then gives you this interesting effect at the end. So we can specify which channel we want to use as our X, which channel we want to use as our Y, and then it takes care of the rest. Definitely play around with this. There's some super, super cool effects that you can accomplish with this. And then at the end of this, we assign this value to a variable that we're going to call displacement. And again, this isn't a full programming language, but it's close enough that we can sort of pass one thing into another and compose our filters together. So the last thing we're going to do here is take that displacement and put it inside of another filter effect called Gaussian Blur. This one is very common for use with drop shadows, for example, because it blurs some sort of geometry. So if we didn't have the other filters and just passed the text directly into this filter effect, then we would just get a blurred version of the NDC text. But what we've done is taken the output of our displacement map and then fed that into the Gaussian blur. And so now we've got this weird blur effect on top of everything else. Filters do respect the order in which they're declared. So if we swapped these out, so we put the Gaussian blur above the displacement map, we'd have a totally different appearance. So again, awesome to play around with. I've lost a lot of hours just poking around, playing with different values, all kinds of stuff for this. But we're not quite done. There's one more thing we can do with this. Let's actually get some animation in here. So what we've seen so far is some CSS animations, but unfortunately, CSS animations don't usually work with attributes. And as we saw with the rectangle to begin with, we can't always use CSS to change attributes of our SVG. Fortunately, SVG provides this animate tag that will allow us to animate certain values. And this is ultimately sort of a brute force method. It just loops as quickly as it can and then updates values based on the number of steps that you provide over a certain duration. In this case, I'm saying I want to change the base frequency of our turbulence from 0.05 to 0 over the span of 10 seconds. I'm cheating a little bit because I don't really like the way that this video plays normally. I'm actually telling it to reverse. That is unfortunately not something we can easily do with SVG in this example. There are some plugins that will be able to do this for you. I just have it on a loop so that it looks prettier, to be honest with you. But other than that, this is how we're doing the animation here. Now, the attribute type can either be XML or CSS, so you can still use this approach to animate CSS properties. But honestly, if you can animate it in CSS, just animate it in CSS. It's a lot easier to read as far as I'm concerned. And you can use things like keyframe animations, which are way more powerful than this, which is simply a linear go from point A to point B over time period T, and then go from there. You can also tell it how many times to repeat. So in a normal example, this goes from the really grainy version to almost the flat version that we're about to see shortly, right around there. And then it just starts over at the super grainy version and does all of that again. I would recommend using filters with discretion. They are super, super powerful. They also take up a lot of resources of your browser, especially if you're doing something like what we saw. It's very graphically intensive, and SVG usually doesn't have access to your GPU, so a lot of this is done directly on the CPU, which can seriously slow down your websites. Keep that in mind, and again, use this with discretion. Make sure that you're using it with a purpose, and especially do some testing on older browsers, mobile phones, that kind of thing, to make sure you're not detracting from the rest of the experience in your application. So now I'm going to introduce you to an app that I built a couple of years ago. This app is called Heartpoints. So I do a lot of tabletop role-playing games. I'd be happy to talk your ear off about them later. I'm going to save you from that right now. But this application tracks a number called your hit point total, which is an abstraction of how healthy that player is. So if the number goes to 0, they fall unconscious while they're exploring the dungeons. Normally you want to keep that fairly high. But it's a number that changes fairly frequently throughout the course of a game, frequently enough, and there's usually enough other stuff going on, nobody really remembers what the number is, and people forget to write it down, all kinds of stuff. So I figured, well, throw an app together and see what happens with it. So that's what this app is. It keeps track of that number for you. But I didn't want to just use normal HTML and CSS. This actually is a React app, not React Native, just normal React on running on PhoneGap. It is on the iOS App Store if you're interested. But I didn't want to just use normal document flows, boring, enterprisey looking app stuff, which unfortunately, and I apologize if any of you have hit point apps in the App Store, most of the other apps that I found looked fairly dull. So I wanted to sort of spice things up a little bit. This application is built entirely with SVG, as I mentioned a couple of times earlier. And there's a couple of specific things that I did with it that we've already covered a little bit here so far today. So the most obvious is custom shapes. So it's really difficult to get a button into the shape of this heart inside of normal CSS and HTML. So I was able to use a path element and draw this custom UI that I exported from Adobe Illustrator. So I did most of the design there, exported it to an SVG, brought the SVG piecemeal into a React app, and then everything just worked because it's normal HTML. I did some styles on it, and everything kind of lined up just fine. So if you're trying to do a UI that has some especially custom shapes to it that aren't easily represented in the normal sort of rounded rectangle world that we live in now, SVG might be a good place for that. I also used blend modes fairly extensively here. You might see when the left and right buttons, the plus and minus, get tapped, the colors change, but it's not quite a black and white. It's a little bit of a saturation shift behind it. That's because everything here is also using a blend mode. So I'm using screen and multiply for the button taps so that it just looks a little bit more natural, especially with colors like pure white and pure black. Any kinds of normal blending modes tend to shift the color out of its normal hue, and they just look a little bit weird. So using some of these other blending modes can definitely help reinforce the color scheme that you've probably worked on fairly hard with your applications and your designers. Now, another place that I used blend modes fairly extensively, if you look at the bottom under the where it says 50, and then when we change the values, we see a little slide out on one side. Believe it or not, everything that is below that heart, so the little rounded box with the 50 in it and the number next to it, is actually black and white. So the background is completely black and the foreground is completely white. Well, how do we get it to this point? Well, it turns out if you use certain blend modes, they ignore black values. So if you use a blend mode that's purely additive, it's going to add a value of 0 for black pixels and add a value of 1 for white pixels. And so what that means is you can actually create UIs like this, where the button technically has a black background, but because of the blending mode we're using, it knocks out the background and produces this kind of interesting intermediary effect. And then finally, as you notice, as the shape inside of the heart itself is going up and down, I use a clip path for this one. So ultimately, there is a rectangle inside of this application, and its height is based on a percentage of whatever your current hit point value is compared to the maximum. And then we resize that with a little bit of an animation as the value goes up and down. And I added a clip path to that that's the same shape as the heart so that it looks like it's being drawn inside of the heart instead of sort of outside of it. So a lot of the things we've already talked about today are in this app. I'd be happy to go into more detail with this after the talk's over if you're interested in some of the more detailed parts of it. Unfortunately, I do sell this, so the code is not open source, but if you are interested in it, send me a tweet or something, and I can absolutely hook you up with it. I just don't want to have the code and all of my private Xcode keys and stuff out for the public to find. So if this has somehow inspired you, you're interested in some SVG and curious about where to go next, a couple of documentation sites I highly recommend. The first one is Mozilla's developer documentation. Honestly, I'm in love with this thing. It's called MDN normally, so anytime I Google something that's web-related, I usually Google MDN, and then I put what I'm looking for. It's a lot better than W3 Schools, and it goes into a great amount of detail on how to use all of the stuff that we've talked about today. CSS Tricks, another fantastic site. They have, as they call it, their mega list of SVG information. It's a couple of years old, but it has been updated once or twice since then. There's still a lot of very valid information. SVG ends up actually being a fairly standard and solid spec. So things are changing, but not super, super quickly. So even though it's a couple of years old, still a very, very valuable resource. Finally, all of these slides are online. If you go to bit.ly/NDC Oslo-SVG, you can see everything that we've had here, except a couple of typos that I fixed this morning. So don't judge me too harshly on the slides that are up on that URL. So with that, I think we have a few more minutes, but I really appreciate you coming by. If you don't want to ask any questions here, I will be hanging out afterward. I'd be happy to discuss more about SVG or what I do at Vectra. Do remember to put in your little evaluation thingies at the end. That's how NDC knows whether to bring me back or not. And I really appreciate your time. Thank you very much for coming. So it's a little difficult to see, but if anyone has any questions, I've got a few minutes. All right, cool. Thank you. Again, I'll be up here, so if you do have any questions, feel free to come up and ask me. Thank you.